Good evening and welcome, students, for another interesting session. This session will be mainly quiz question answer sessions, as we have been telling you about the gravitation, and certain things are known to us about the gravitation, that every object in this universe attracts every other object by a force which is called the force of gravitation. And we know that this gravitational force is very weak. That is why we don't detect this in ordinary objects on our earth. That means there is some force of attraction which is existing between every object, but that amount is so less, that is so small, that we are not able to experience it and observe it. Is it right or wrong, students? Tell me, is that what we learned?
Yes, sir.
Okay, keep on talking with me, keep on interacting with me, because we have to keep our energy levels high. Our energy is inside us. We must be able to awaken our energy levels and keep them active all the time. Your life is all about inspiration, life is about enthusiasm. If we will be inspired, if we will have enthusiasm, we will enjoy the life, or we will be behaving like dead bodies. तो हम तभी एक्शन में आएंगे जब हम एंथुजियाज्म होगा. प्लेयर्स के अंदर बहुत बड़ा एंथुजियाज्म और एक्साइटमेंट होता है, तब तो वो गेम जीत जाते हैं. देखा नहीं कैसे वो खेलते हैं बुरी तरह, और कितनी एनर्जी होती है, कितनी एक्शन होती है. किसी भी चीज़ की, किसी भी गेम को ऑब्जर्व करोगे तो प्लेयर्स के अंदर कितनी ज़्यादा पावर होती है. स्टूडेंट्स, अगर उसकी एनर्जी ड्रॉप हो गई तो वो हार जाएगा गेम को, ये भी आपको पता लग चुका है. हमारे और तुम्हारे दरमियान में एक एनर्जी का लेवल है, अगर हमने उसको कम कर दिया तो हम भी हार जाएंगे. इसलिए हमें मेरे साथ बातचीत करिए, इंटरेक्ट करिए और क्वेश्चन आंसर सेशंस में पार्टिसिपेट करिए. तो हमें ये पता लगा कि स्टूडेंट्स, एवरी ऑब्जेक्ट इज अट्रैक्टिंग एवरी अदर ऑब्जेक्ट इन द यूनिवर्स. और न्यूटन्स ने एक लॉ ऑफ ग्रेविटेशन दिया जो हमें पता है, विच विल बी डिस्कस टुडे. एंड वी नो दैट देयर the moon is orbiting around the earth because there is a centripetal force which is acting on the moon, which keeps it in the circular orbit. Is it true or is it right or wrong, students? जल्दी से बताइए.
Sir, it is right.
तो centripetal force origin, what is the origin, where is the origin of the centripetal force? Centripetal force का मतलब क्या है? Where it is coming from? Tell me, where the centripetal force is coming from, students? The gravitational force of earth is responsible for the centripetal force which the moon is experiencing. That is why it is orbiting and moving around the earth. और इसको अगर भी ड्रा कर लेंगे, ग्रेविटेशनल फोर्स जीरो होगी तो क्या होगा फिर? देयर विल बी नो सर्कुलर मोशन ऑफ द मून, इट विल फ्लाई ऑफ. ये कहीं और चले जाएगा. इतना बड़ा यूनिवर्स है. as there are so many other galaxies and so many other particles, big particles also in the universe which are floating. तो अब देखते हैं कि हमने ये बताया कि there is a free fall of the objects, and the objects, when the earth has a gravity, it is attracting the objects towards itself, and there is a free fall of the objects which we call as, due to which there is a acceleration due to gravity experienced by the objects. इसके ऊपर we will be discussing these type of questions in the quiz which is in front of us, students. And we have calculated the value of small g and big G value is a universal constant. Does the value of big G change anywhere? Tell me if the value of G will change if I go to moon. Big G. There are two G's which we have talked, small g and big G. तो बताइए, what will happen to the value of big G if I go from earth to moon? क्या होगा? जल्दी से बताइए. स्टूडेंट्स, आपकी एक्शन जरूरी है. तो ठीक है, फिर लेट अस स्टार्ट द क्विज, स्टूडेंट्स. आई होप वी आर एक्टिवेटेड. वी हैव डन द सम वार्म अप एक्सरसाइज हैज बीन डन. वार्म अप एक्सरसाइज कर लिए, माइंड हमारा ठीक हो गया, एक्टिव हो गया. So we will be answering the question. The question number 1 is on the screen, students, for all of you. Question number 1. What is the question number 1? Says the earth attracts an apple. Does the apple also attract the earth? If it does, why does the earth not move towards the apple? Answer the question. You have 1 minute, students. जल्दी से बताइए. Answer 1. What is your answer, students?
So, so the earth attracts an apple, and so does the apple attracts the earth with an equal and opposite force. Mass of the earth is extremely massive as compared to that of the moon. So the
Oh,
acceleration produced is very small as compared to that in the apple.
that is the correct answer given by Vidhi. Absolutely right answer. That the attraction of the earth and apple are equal and opposite. There is no doubt about it. So, but the force you said is equal to mass into acceleration, and the acceleration which is produced depends on the force by mass. So small, this mass is very small. So the acceleration that will be produced in the apple will be very, very less as compared to when it is moving towards the earth. So the forces are the same, but acceleration are different in the two cases. So that is the reason the force with which Earth is attracting, and the apple and apple attracting the are equal, but the acceleration produced are not the same because the mass of the apple is very, very small as compared to mass of the apple is very, very small. Therefore acceleration that will be produced in the apple will be very, very large. As if I put the mass of the earth, then acceleration that will be produced on earth will be very, very negligibly small. Correct answer has been given by the student. Therefore students, you are given 1 mark here. Next question on the screen for you, the students. Mention any four phenomena that the universal law of gravitation was able to explain. What
Sir,
was?
the universal law of gravitation successfully explained the force that binds us to the earth, the motion
Okay,
of the moon around the earth, the motion of planets around the sun, and the tides due to the moon and the sun.
motion of planets around the sun, motion of moon around the earth. Keep on writing in your notes, because in the paper when such a question will be asked in your exam, you will be able to answer with great confidence because you are so well, you have done good practice and you are aware of it. The tides due to gravitational force of the moon, you are saying, students. So this is the correct answer. Anya gives the correct answer. Anya, and with the correct answers given, you are right. You are right. You are getting 1 mark here. Question number 3 is on the screen, student. This is a quiz. Participate and enjoy the quiz. And this will help us learning the gravitation chapter, because whatever we have studied, we will be able to learn more by answering these questions. Why does an object show weightlessness? Weightlessness.
Weightlessness, so weightlessness is a state when an object does not weigh anything. So basically, it occurs when a body is in a state of free fall under the effect of gravity.
Absolutely correct answer. You have seen that you will experience weightlessness if you dive from the plane, and what will happen towards the earth. See, when their objects are falling freely under the acceleration of the gravity, then what will happen? So, when there is a free fall, when there is a free fall of the objects, so they will experience weightlessness is the correct answer, student, which has been provided by Vidhi. You are getting 1 full mark in this question also. Now coming to question number 4, students. Why does a body reach the ground quicker at poles than at the equator when dropped from the same height, students?
Sir, the acceleration due to gravity is more at the poles than at the equator. So when the body is dropped from the same height, the body reaches the ground quicker at the poles than at the equator.
That is the correct answer which has been given, because the g is equal to gm by r square. And since at the pole, if we say you have seen the earth, if it is bulging out student, and what is happening, this, you have seen, this is r, this is a bigger r, this is larger than this is my pole, this is my equator students. So naturally this r is small, then this value of g is more here, this value of g is more here, and g is less at the equator. So acceleration due to gravity, you are saying acceleration due to gravity is more at pole and less at equator, right? Okay, correct answer given by Anya. You are getting one full mark for this. We can see the formula also is before us on the screen. Okay, next question before us. What is the source of centrifugal force that planet requires to revolve around the sun? On what factor does this force depend, student? From where the centripetal force is coming? Question number
So,
5.
centripetal force is needed to make an object move in a circular path. In this case, the centripetal force is provided by the gravitational force of the sun. This force depends on the masses of sun and the planet as well as the distance between them.
Very good answer given by Vidhi. This will be due to the gravitational force of sun. Correct answer. And we already know that what will be the value of this centripetal force, which is given as mv square by r. So radius, distance, and this is the correct answer. You are getting one full mark in this question also. Answer correct. Okay, question, another question on the screen, student. Certain questions have been taken from exemplar, important questions from the NCERT, and some questions have been taken from other previous papers which have been asked to the students. Suppose that the radius of Earth becomes twice of its original radius without any change in its mass, then what will happen to the weight, student? What will happen to the weight?
Sir, we know that F is equal to gm into m upon r square, as the weight of the body is the force with which a body is attracted towards the earth. If we double the original radius, then W will be equal to gm into m upon 2 r square, and our weight will be reduced to 1/4 of the original.
Okay, that is the correct answer which has been given by Anya, is saying that F is equal to G M into M. There are two bodies. This one is Earth. ठीक है? And this is my radius of the Earth. This is the mass of the object, and this is the radius of the Earth, r square. So if this is my force 1, if r force 2 is g, mass of Earth is the same, this is same, students, and re becomes twice of re the square. So then F2 by F1 will be how much, students? F2 by F1 will be how much? So what you are getting, students? F2 by F1, 1 by 4. So the force will become 1 by 4 of F1. Correct answer has been provided. So you're getting one mark here. Okay. Next question on the screen, students. Prove that if the earth attracts two bodies placed at same distance from the center of earth with the same, their masses are equal, their masses are equal. Two bodies placed at same distance from the center of the earth. If earth attracts two bodies placed at same distance, then what we are saying, from the center with the same force, then prove that their masses are equal. Students, what formula you are using? Same formula, same formula you are using, students.
So
F1 is equal to g mass of earth, and m1 is the mass of the object, r is the radius of the earth. F1 and F2 will be g mass of the earth is same, m2 is the mass of the object, r square e radius of the earth, and it is given with the same force. F1 is equal to F2. Then I put these two equal, then what will happen? This will cancel out, and you will get m1 is equal to m2. That is the answer which you have given, right?
yes,
Okay, that is the correct answer given by the students. You are getting one full marks. We have to show this in the exam. That is a derivation which has to be shown by the students. Next question on the screen, students. Give three differences between acceleration due to gravity and universal constant. You have to.
Sir,
हाँ bolo.
the
Yes.
universal constant is a weak force, while the acceleration due to gravity is a strong force. The universal constant is equal to g into m1 into m2 upon r square, while acceleration due to gravity is equal to m into g. The direction of gravitational force lies in the radial direction from the masses, while the acceleration due to gravity the direction of the acceleration due to gravity is along the line joining the earth's center and the center of the body. And the universal constant requires two masses, while acceleration due to gravity requires only one mass.
Any other things which you want to say, Vidhi?
yes, sir.
What you want to
So
say?
the value of G remain constant everywhere, while that of G varies. And G is called as universal gravitational constant, and G is acceleration due to gravity.
ठीक है. Small g value changes from place to place. You know about it. Even for Earth, we have said that it is more at the pole and less at the equator. And when you will go to the moon, the value will change. 1/6 of the Earth, we have calculated that. And G is a universal constant. Its value is not changing. It will always be same anywhere you can go. This is a constant value. Then if how do you define G? We already know. If you want to define G, this is force. If this is one, this is one, this is 1 unit, then F becomes equal to G. So it does not, it is for the unit masses and unit radius, that is the G, and small g is a vector, whereas G is a scalar. So these are some of the differences which you have told. They are correct answers. They are correct answers. So we can say that you are also getting 1 mark here, students. All the answers have been answered. How many marks you have got here, students? This is the first set of this 1, 2, 3, 4, 5, 6, 7, 8. So here the students are getting 8 out of 8 marks. All the questions answered correctly. Okay. All right. Further, we are coming to important question on the earth, a stone is thrown from a height in a direction parallel to the earth's surface, while another stone is simultaneously dropped from the same height. Which stone would reach the ground first and why?
So, so both the stones will take the same time to reach the ground because the two stones fall from the same height.
That is the correct answer. Correct answer. Very good answer given by Vidhi. Both the stones will reach. Both stones will reach the ground at the same time. They will reach the ground at the same time because they are dropped from same height. From same height. Correct answer. You are getting one full mark here. Coming to the next question, student. Calculate the average density of the earth in terms of small g.gr. We have to find a formula, student. You have 2 minutes to derive the formula for this. Average density of the earth by using small g, and r. Calculate the average density of the earth. What the formula looks like? If you can assume earth to be spherical, you can assume earth to be a sphere, then the volume of the earth will be what? 4 by 3 pi r cube. Volume of a sphere, you know, and what is the formula of the density? Mass per unit volume. Mass per unit volume, student. This is the mass of the earth. This is the volume of the earth. So this is the radius of the earth. Then you have to use small g, and r. What is the relationship between small g and big G? You know the formula? This one. So mass of the earth calculated by this. What will be that? Mass of the earth, small g, r is square by m. So here you have mass of the earth, you have volume of the earth, then what is the answer coming? What is your answer, students?
So 3 into small g upon 4 pi into rg.
That is the correct answer has been given by Anya. You are getting one full mark. See, all the thing was just to put the values. So you have g r e square by me divided by 4 by 3 pi r e the cube. So whatever is cancelled, you will cancel and you will get the value 3 by 4 pi, 3 by 4 pi, and g by. So you have, where was it? Me g me is equal to g into r square m by g also. So what will be that? 4 by 3 by 4 by g into r. That is the answer. Okay. That is the correct answer. You are getting 1 marks here, student. Correct answer has been given. Now the next question is on the screen, students. What will happen to the gravitational force between two bodies if the mass of one body is doubled?
Sir, if the mass of one body is if the mass of one body is double, the force will also be doubled.
Force will be double because what is the formula? F is equal to G m1 m2 by d the square. So if mass is doubled, this is my F1, then F2 will be G twice of m1 into m2 by d the square. Therefore, F2 by F1 will be equal to 2. So F2 is equal to twice of F1. The force will be double. That is the correct answer has been given by Vidhi. 1 full mark for that question is answered. Next question before you on the screen. Why is G called universal gravitational constant?
Sir, G is called the universal gravitational constant because it is constant throughout the universe.
It is constant everywhere. That means you are saying F is equal to G m1 m2 by d the square. M1 is equal to 1, M2 is equal to 1, D is equal to 1 unit, then F becomes equal to G. So the gravitational force is equal to, this G is nothing but gravitational force when we have unit masses and the unit distance between them. So it doesn't depend on the masses, it doesn't depend on the distance, because so that is why it is universally constant. Universally constant. Okay, correct answer. 1 full mark here. Who formulated the universal law of gravitation, students?
Isaac Newton.
That is the correct answer. Isaac Newton. Isaac Newton is the correct answer given by Vidhi. You are getting 1 full mark. How is gravitation different from gravity?
So, gravitation is the attractive force existing between any two objects that have mass. The force of gravitation pulls objects together. Gravity is the gravitational force that occurs between the Earth and other bodies. Gravity is the force acting to pull objects towards the Earth.
That is the brilliant answer given by Anya. Can't believe you people have mastered the subject so well. In a short period of time, you are becoming very good in science. 100 out of 100 marks you are getting. There's a correct answer that when I talk of gravity, I'm talking of the Earth's attractive force between Earth and other objects, whereas gravitational force is between any two objects anywhere. So gravity, that's why we say Earth's gravity, Earth's gravity. So when we talk of Earth, that is the gravity, student. That is the correct answer given by Anya. You answered the question so well. Okay. Question number 5 on the screen, student. What does a small value of G indicate?
So the small value of G indicates that the force of gravitational attraction between two ordinary sized objects is a very weak force.
Very weak force. That this force is very weak, very weak. Correct answer given by Vidhi. So good, so well. That is why we are not able to experience between this force between the objects which we are of ourselves, or the objects which are on our planet. They are not attracting each other. They are not orbiting, or they are not orbiting around each other, because the gravitational force is very weak, very, very weak. Correct answer has been provided. Very weak. Okay. We know that the value of G, if I put here, then this force becomes very, very small. If the masses of the objects which we experience in our on the planet. So bus is not attracting me. Bus is not attracting me. I am not orbiting around the bus, because if I put the masses and the distance, then I will see this force will be very, very negligible student. Therefore, we will not be able to experience it. We will not be able to. That is the answer given by Vidhi, correct? Yes? Or if this was a strong force, then what would happen? Then what will happen? Then we will all be attracted and colliding with each other. So, okay, that is another good part, that the force is very, very weak. So we are not able to experience that between our objects. Question 6 on the screen. At what place on Earth's surface is the weight of body maximum?
Sir, the weight of body is maximum at the poles.
Because m into g, so m into g, weight is m into g. At the pole, g is maximum, g is more. So at the pole is the correct answer, has been given by Anya. You're getting one full mark here. One full mark. The question 7 is coming on the screen. Students, question number 7 is on the screen. At what place on Earth's surface is the weight of the body minimum?
Sir, at equator.
Correct answer has been given by Vidhi. Again, at the equator, because the value of g is the smallest at the equator. At the equator. So, how many marks we have got here? Students, you got 1, 2, 3, 4, 5, 6, 7, 8. You are getting 8 out of 8 marks here also. So, excellent and great performance given by the students. Okay. Question 8 is on the screen, student. Question number 8 is on the screen as a quiz competition going on between students, and they are doing so well. They are prepared as well as they have understood the chapter of gravitation. In case of doubts, you have the video lectures already. More than 10 video lectures are with you. They are available in the YouTube. You can listen and share with your friends, students. You can share it with your friends, no problem. Question 8 on the screen. If the mass of the body is 9.8 kg on Earth, what would be its mass on the moon? What would be its mass on the moon, students? What is your answer, students? Why you are taking that much time? What answer you are given?
Sir, as the mass of body is constant everywhere, the mass of body will remain same on the moon.
Correct answer. Anya, you are taking correct answer that mass is a constant. Mass is always constant. It is the quantity of matter contained in a body. Quantity of matter contained in a body, that my quantity will not change if I go from Earth to Moon, students, or any object you take it. M is not changing. So its value would be the same. Same. Correct answer. Okay. Next question on the screen has come forward, student. Can you tell me the answer of the question 9? Do fluids possess weight? Do the fluids possess weight, students? Yes or no?
The specific weight is defined as the weight possessed by a fluid.
My question is, do the fluid possess weight? Do they have weight or not? Fluids have got weight or not? That is the question. What are fluids? Can be liquids or gases. They are all fluids.
Yes, sir. Yes,
They,
sir.
yes, they have weight. Fluids have weight, whether it is any, you can take air or you can take Water, they have weight, student. Fluid, you know the weight. Weight was the responsible weight. Due to the weight, they were exerting pressure. And we have done an experiment also to show that the liquids were exerting pressure. And with the increase in depth, the pressure was increasing. Okay, correct answer. Yes, they do have. Anya, correct with the correct answer. Next question. Why can one jump higher on the surface of the moon than on the earth? Students, you are an athlete and you are jumping on the earth, then you go to the moon, what will happen? Your jump will be higher or lower on the moon? What will happen? If you try to jump on the moon, students, what will happen?
Sir, it will be higher.
Higher. Why one can jump
Sir,
higher on the
because
surface?
the acceleration due to gravity on moon is less than the acceleration due to gravity on earth, and acceleration due to gravity has no effect on horizontal motion.
Okay. What is the value of G on our on the moon? You know how much is that? We calculated. What was that? The value of G on moon came out to be how much? 1/6 of the earth. So the value of G is less on the moon. Therefore, you will jump higher. I don't know how high, 6 times you will go, 6 times what you are jumping here. So will those type of games be possible there? I don't know the athletic movement. See the story, the value of G has changed on the moon. Okay, that was a correct answer. Interesting to sometimes compare what things will be possible, what will not be possible, students, and how they will affect the rate of the speed of the cars there. If the same car goes there, if the same speed, then what will happen? Because the force of gravity, the the force of the gravitational force is less on the moon. Then what will be the result of that? Define the standard kilogram. You should know that there is a SI. These are SI units, student, standard kilogram mass. There is an international bureau of weights and measures. International bureau of weights and measurements. International bureau of weights and measurements is their students. International bureau of weights and measurement is there. So they have in the Paris student, near the in France, they have kept a alloy of platinum which has 1 kg as a standard 1 kg mass. With that we compare everything. Standard 1 kg mass. Oh, every 1 kg can be compared with that. That has to be the same. It cannot be different. These are called standard international units, accepted everywhere in the world. Okay. Next question is on the screen, student. If Earth attracts two objects with equal force, can we say their masses must be equal?
Yes, sir.
Make sure you are able to think about it. You have one more chance to answer this question. If Earth attracts two objects with equal force, there are two objects, one is heavier, one is lighter. They are being attracted by the equal force by the
So,
Earth.
no.
So make sure their masses can be different, no problem. You can throw two things, heavier and lighter. from the same height, what happens to them? They reach the ground at the same height. They will experience the same gravitational force, student, and acceleration due to gravity is g is equal to g m by r square. It is not dependent on the mass. What formula you gave? G mass of earth, radius of earth the square. This value is not having any mass of the, there is no mass of the objects. So this answer is no, students. Zero mark. Okay. Is weight a force?
Yes, sir.
Yes. Is the correct answer given by Vidhi? Yes. What is weight? Is mg. Weight is a force with which the objects are attracted by the gravitational force of the earth. Okay. Correct answer is there. What keeps the moon in uniform circular motion around the earth? We have answered this question many times, students.
So, gravitational attraction provides the centripetal force needed to keep planets in orbit around the sun and all types of satellites in orbit around the Earth.
That is the correct answer. The correct answer you are saying is this is a centripetal force which keeps the motion of the moon around the earth, and that is provided by the gravitational force of the earth. Centripetal force is due to the centripetal force that moon is orbiting around the earth, and the force is due to the gravitational force of the earth. Centripetal force keep the moon around the earth, and who provides the centripetal force? Earth. Gravitational force provides the centripetal force. Okay, that is how we say the answer is right. Then one mark is given to Anya. When a body is dropped from a height, what is its initial velocity, students?
So 0 meter per second.
Okay, correct answer. So fast, students. That initial velocity is at rest. Initial velocity when the body was at rest, student, u equal to 0 is the correct answer, has been given by Vidhi. So you are getting one full mark for that also, student. Next question is on the screen for you. When a body is thrown vertically upward, what its final velocity?
Sir, when a body is thrown vertically upwards, its final velocity becomes zero.
That is the correct answer. When body goes here, then it stops, then it will start coming back. So final velocity, it was having some initial velocity, but this v will be zero. Correct answer. Correct answer has been given. Ane, you're getting one full mark for that. The final velocity is zero. We will use that a lot in our numericals. Is the time taken by a body to rise to the highest point equal to the time taken to fall from the same height, students? If the body takes from, it goes from here to here, how much time it takes? 5. Supposing it takes 1 minute from this to this place, will it take the same time from here to here?
Yes, sir. Same time.
Same time is the correct answer, has been given by Vidhi. And how do you calculate this answer? You know that V square is equal to U square plus 2 AT formula we have seen. U square is equal to V square is equal to U square plus 2US. 2US formula you have seen. G value, where is the G value is same, and S is equal to ut plus half. S is ut plus half AT square. With that formula we can calculate the time taken. V is equal to U plus GT. V is equal to U plus GT. G is same, student. G is same, plus and minus sign only. Plus and minus sign changes. Okay, this how many marks you have got here then? 1, 2, 3, 4, 5, 6, 7, 8. You are getting 8 out of 9 here. Okay, next question, student. Is the acceleration due to gravity acting on a freely falling body directly proportional to mass of the body, time of the fall of the body? What is the answer of this? The acceleration due to gravity acting on a freely falling body. Is it directly proportional to mass or time of the fall of the body? What is your answer, students?
So the acceleration due to gravity acting on a freely falling body will not be directly proportional to the mass of the body.
And time of fall of the body? What is the formula of the small g? Does it have anything mass or time? So what is your answer, students?
Sir, it will be inversely proportional to the time of fall
Where
of
is
the body.
inversely? Nothing. So you are getting half here and you are losing half mark here. It does not depend on any of these things. There is nothing in here. Acceleration due to gravity. It is not changing. We already said it is, the value is 9.8 meter per second square. 9.8 meter per second square. Where is there's nothing mass, only mass of Earth and radius of Earth. It is not the mass or the time of the fall of the object. Okay, next question on the screen, students. Suppose gravity of Earth is suddenly become zero, then what direction will the moon begin to move if no other celestial body affects it?
So the moon will begin to move in a straight line in the direction in which it was moving at the instant, because the circular motion of moon is due to the centripetal force provided by the gravitational force of Earth. And if gravitational force becomes zero, it means no centripetal force is there to help the moon to move in circular orbit. Therefore, it will move in a straight line.
Correct answer given by Vidhi. Very, very good answer. Very, very good answer. This is your Earth and this is your moon. Moon. This is your moon. And there is a centripetal force with which it is attracted towards the Earth. This is our moon. And if this is not there, what will happen? If it was here, it will just go in a straight line. It will move in a straight line because this force is no longer there and other objects are not attracting. So what will happen? That is the correct answer has been given. Okay, 1 mark here. Question number 20 on the screen, students. Earth is acted upon by gravitation of the sun, even though it does not fall into the sun. Why? What is your answer, students?
Sir, the Earth does not fall into Sun because Earth keeps revolving around the Sun, which creates a centripetal force that pulls Earth away from the Sun. When this force is equal to the gravitational attraction, Earth becomes stable. That is, it never falls into the Sun, nor it leaves the Sun.
Yes, we have told you to every action equal and opposite reaction. Centripetal force is there, which allows the Earth to move in around the Sun, which is given by the gravitational force of Sun. But at the same time, there will be a force which is called centrifugal force, which keeps the objects away. So the equal and opposite forces are always there. Centripetal force, centrifugal force we will read in further higher other classes later on. So that is how the earth is keeps on moving in orbits around the sun. That is the correct answer given by Anya. You are getting 1 marks now. So how much was the story here? Here you had 2.5 out of 3 marks. So what is the total score, students? What is the total score you are getting? Let us see. Here 8, how much then? 16 out of 16. Then how much? 16 plus 8, 24. 16 plus 8, 24 out of 25. And finally here you are getting 27 and 24. How much is this? 25, 28, so 26 and a half. So that, well done, and keep it up. You can get easily 100 out of 100, students. That is our target 100 out of 100. So our target is always 100 out of 100, students, and therefore the quiz ends here with excellent performance given by the students. And we are going to discuss the new chapter, which is atom. The next chapter, which is on the coming for a student, which one is that? Atomic structure.
Yes, sir, the structure of an atom.
So we will be going ahead with the structure of the atom, students. And in between, if we will like to give a test, we will inform you. Okay, then bye bye. We will meet you in our next class. So it was a good performance and good energy level, high interaction, high. You can share our videos with all your friends. Have energy, have action, and keep working for the final papers which are coming in March, students. My best wishes to all of you.
Thank you,
Thank you,
sir.
sir.
Okay, we'll meet you in the next class.